Welcome everybody. Our next speaker is Isaac Udy. He's a Android Platform Lead at ANZx. He's talking about reimagining navigation on Android. His favorite ice cream flavor is vanilla bean, but with navigation, it's not as vanilla. So welcome, Isaac.
We're getting favorite here.
All right, now that I have the mic and Zach hasn't run away with it, yes, welcome to Screens of Functions, Reimagining Navigation on Android. As Zach said, my name's Isaac. I am the Android Platform Lead for ANZ Plus, or ANZx as it's sometimes known, and I'm also a Google Developer Expert for Android. And over the past few years, I've got quite interested in navigation and spent a lot of time thinking about navigation, which is why I would like to start this session by talking a little bit about thinking. And by that, I mean mental models. I'd really like you all to take a moment and think about what a mental model is or means to you. To me, a mental model is sort of a shortcut to abstraction, a simplified essence of an idea that helps us understand the behaviors of things, how they fit together and work with one another. These help us reason about ideas and they influence the way we think. In some ways, they really are the way that we think about concepts and ideas. And that, in turn, influences how you communicate about ideas, both internally or externally to your teammates. And this really has quite an influence on what you build, or what you might even consider as being possible to build. And that's what I want us to think about a little bit today when we ask, or when I ask the question, what is a screen? So just pause for a moment. What is a screen? You're building an Android app. What is a screen? Is a screen an activity, a fragment, or a composable? Well, no, but yes. That is what a screen is, often implemented as, but that's talking about implementation details. That's not the essence of a screen. It doesn't tell us about its behaviors. How about an element in a backstack or a node in a navigation graph? I mean, stacks and graphs are just data structures, and membership or being part of a data structure, again, doesn't really give us any information about what a screen is. A named collection of UI elements. I think this is kind of getting a little bit closer to what the idea of a screen is, but it's still a little bit vague, and I feel like it doesn't really capture any of the sort of behaviors or how these collections of UI elements might interact together, or really provide us any shortcut to abstraction when we're thinking about it. Instead, I would like to suggest that the most common way that Android engineers, or really any application engineer, thinks about screens is that a screen is a location. That means it's a place that you send the user, somewhere that the user travels to or goes within the digital landscape of your application. And I think there's a few reasons why this fits well for most people's mental model, whether they know that that's the way they're thinking about things or not, is because this matches the way that the internet works to some degree, right? We're all very familiar with using the internet and typing an address into the address bar to go to a web page to some location. And that means that this model of thinking about screens as like locations where you go is comfortable and familiar. And so of course we would bring that idea with us when we go and look at building Android applications. And I think that this idea of navigation sort of fits in nicely with those data structure concepts, or data structure concepts I was talking about before with backstacks and navigation graphs. A backstack is a history of where the user has been. And a navigation graph is kind of like a map of where the user has been or could go in the future. And there are other metaphors around navigation in our applications that also fit in quite well with this idea of a screen being a location. For example, most applications have something called a home screen. you might talk about the home screen of an application. And why do we call it home? Well, because most of us every day start out at home before we journey out into the world, which is kind of feels familiar when we're talking about an application. You start at home before you journey out into the rest of the application. You might navigate forward or backward through the application, which sort of lends that idea of movement. And even the word navigation itself is actually kind of quite closely tied to the idea that a screen is a location. To quote Wikipedia, navigation is a field of study that focuses on the process of monitoring or controlling the movement of a craft or vehicle from one place to another. Obviously, we're not dealing with crafts or vehicles, but we're certainly dealing with moving users from one place to another. So I've said mental models shape the way that we build software, what we consider as being possible. And taking this idea that a screen is a location, how does this shape behavior? Or really, how do I think this shapes our behavior? And there is one particular way that I see this mental model shaping our behavior that I think is problematic. And that is that a location doesn't produce anything. The idea of a location as a generic concept, locations don't give you anything as a result, right? You might have a location in the real world that does produce something. For example, you might have a car factory that produces cars, but that is specific to the detail of the car factory. It's not any location produces some value. So this means that navigation frameworks that we often use when building applications don't really consider results to be a particularly important or core concept. And they're tacked on as an afterthought to navigation, which I think is a problem and really limits the way that we can build and structure our applications. So let's look at an example of what I mean by results being sort of tacked on or not very good with existing frameworks that we use in Android. And so I have an example here, and this is from a Stack Overflow answer, or adapted from, there's many answers that suggest this sort of code, which is showing how using AndroidX composed navigation, how you might pass a result between two composable screens. So we have our composable sending screen, which is going to send the result. And to send the result, we're going to grab the navigation controller. We're going to sort of be contextually aware that the previous screen actually wants us to send a result. We're going to grab that saved state handle and then set a key and a value into that screen's saved state handle. On the receiving screen, we're going to have a kind of implicit dependency here, where the receiving screen is going to know that the screen that's sending the result is going to use a particular key. We need to know the type of the result that we're expecting from that other screen. And this kind of implicitly ties the behavior of these screens together. They become coupled to one another. Now, this isn't the only way that you can share results between screens, particularly using Compose and Compose navigation. You could use composition locals to call a callback or do something like that. Or you could use a shared view model. But all of these solutions are kind of outside of the scope of a navigation framework. They're outside of what AndroidX Navigation does, and therefore they don't really tie in very well with navigation. And the screens end up with implicit dependencies between one another, no matter which solution you use. So hopefully this gives you like a little idea of why I think this is a problematic model. Thinking of screens like locations and ignoring results doesn't really give us what we want. So I would like to ask you to consider an example that we're going to be touching on throughout the rest of this presentation, and we're going to get into some real code examples of this. But I want you all to imagine that you're building an app for a conference, and it's for the conference organizers. They can enter details about sessions at the conference, and they can enter details about speakers in the conference. And in particular, there is one flow through the application that we're going to talk about, which is this editing some session details. So on the left here, we have the session details screen. And by tapping on the edit button for speaker, you should be able to edit the speaker for that session by selecting a user or a speaker from the list of speakers in the bottom sheet. Or if the speaker that you're not interested in, or that you're interested in is not in the list, you can tap new speaker where you are kicked off to a sort of multi-stage form input where you enter information about the speaker. And then once you save that speaker at the end of that flow, you are also returned back to the session details screen. And obviously in either case, the speaker for that session should be updated. Looking at this, just have a short think about how you would structure this, how you would split this up. Are these individual screens, or is the session details a single screen with a bottom sheet? Is the flow with multiple screens, is that, or multiple subscreens perhaps, is that one screen? Or would you split that up into really tiny little slices of functionality when you're trying to connect those together? How easy would it be to manage this if you had a different team working on the session details and another team working on the speaker creation flow, for example? How easy would this be to change over time? How easy would it be to understand if you're coming into the project for the first time and trying to figure out what the application does from reading the code? In any case, I think the thing that is most important here and most difficult about this example app and building this is the connections between these individual parts of the application. So it's pretty easy to list a little bit of data, have some text fields and buttons on a screen. Really, in the example app, you know, most of the difficulty is about connecting these screens together. And I think that thinking of screens as locations really limits the way that we look at solving these problems or building this, how we break it down, what we consider to be possible. And so I would like to suggest that there is another way of thinking about screens in our applications, instead of thinking of screens as locations. So what is this alternative mental model that we could use? Well, if we're looking for a different way of thinking, we want something that should be simple. It should be reasonably easy to understand at a high level, in the same way that thinking about screens as locations is an easy way, simple model to pick up. And it should be scalable. Like whenever I'm thinking about problems like this, I really am looking for solutions that are going to work for one person on a hobby project doing something for fun, building an application for fun, and a team like we have at ANZ Plus with 20 different pods and 70 engineers working. You know, there should be a smooth transition from the beginning to the end there. And of course, you've all read the title of this talk. And so the alternative mental model I'm going to suggest is that a screen is a function in our applications. That is, a screen should act like a function acts. It should have clearly defined inputs. Very importantly, and missing from the location model, is that it should have clearly defined output as well. Doing this means that you can make screens more independent. They don't need to be contextually aware to reach into the back stack of a previous screen to set results. And this means that you can have screens which are composable and reusable much more easily, which is really good when you're working with a lot of screens. You don't want to be building the same thing many, many times. You want those to be able to be reused. So I think this model, this idea, is reasonably simple to understand at that high level. I think it's familiar. You know, we, as engineers building software, we sort of know what a good function is and how a function should work. You know, for example, we like to have pure functions where it is predictable behavior based on the inputs. We're not relying on global variables or external state. Our functions are never going to be looking in the call stack to figure out who called them 2 functions ago to change their behavior. That would be crazy. And so these sort of ways of building good functions, if you're thinking of screens as functions, really help us build good screens as well. And I think this idea that we have, or this idea of a screen as a function, is really useful without any sort of tooling that makes it easy. I think it's just useful as an idea to consider how your application fits together and how it is built on its own, just a different perspective. But I think you will get the most value out of doing something like this with some tooling that really supports this model from the ground up. And while you could build your own tooling, I can't tell you what your tooling might look like. So we're going to look at some examples coming up with a library that I have spent the last 4 years working on, which is called Enro, which is built from the ground up to really support this idea that screens are functions and results should be really important to the way that they work, and that screens should be independent and reusable. So I'm going to skip some details about things in the examples and the slides coming up, just for sort of brevity. Otherwise the code might get a little bit too long, or there might be questions you have about what I'm showing. Feel free to ask at the end, or come see me and we can take a look at a little bit of code. But there is also a sample project on GitHub, which I will link at the end, which you can all check out. So we're thinking about screens as functions. And we're thinking about our example conference app. So let's take a little bit of a look at a really simple screen, the session details screen. If we're thinking about this screen and how it fits in with the rest of the application as a function, how might we do that? Well, this would be a really simple function, I think. We're just showing the user details. So our function would be to show session details. We would perhaps take a session ID as arguments, and we would return unit from this because there is no return type. And while return types are important for functions, they are also optional for functions. So in this case, we don't need to worry about it. So taking this idea of this function, we can convert this into some Enro code that would look a little bit like this. So we would take the sort of function signature and create what's called a navigation key. And you don't really need to worry about supports push there, or there's going to be some supports present in other places. That's one of the details we can skip over. But essentially, this is the function signature for our screen. And you'll notice that there's nothing there talking about results. We'll touch on that later. Now, the way that this works with Enro, if you are using composables as opposed to using fragments or activities, you would annotate a composable function and say this is a navigation destination, or show session details. From within that composable function, you can grab a hold of the navigation handle, which provides you access to the navigation key that was used to open the screen, as well as letting you perform navigation side effects, actually performing navigation. So in this case, the example code shows us writing the session ID out as some text, but in reality, you'd probably want to throw that to the view model and load some data. And I said you use the navigation handle for performing navigation as well. So if we wanted to show the speaker details, if we clicked on the speaker's name and not the edit button, that would be reasonably easy to do as well. Assuming we have a navigation key for show speaker details, we can just push to that and the navigation will be performed. Okay, so that's simple, but it doesn't touch on results. So let's look at a more complicated example where we have this bottom sheet that is displayed, and we want to actually send something back, some information back to that session details screen. So thinking about this as a function signature, it looks much the same as the function signature from before. The clear addition here is that we have a return type of speaker ID. So our select speaker function screens returns a speaker ID of the speaker that the user has selected. And we also might choose to provide a currently selected speaker ID as inputs to our function so that we can show a little tick button of the currently selected speaker. Now, how do we convert that function that idea into Enro? Well, it's very similar to before. We define a navigation key. We define the arguments for the navigation key. This navigation key supports present. Like I said, it's not really a concept we need to worry about for now. But the important thing is that the navigation key, that contract there, has a result. It has a result of type speaker ID. And so this navigation key is the contract for our screen. So when we go to use this in our composable, or if we are building a composable screen and we want to use it for a composable screen, we do much the same. We annotate with navigation destination. We get a navigation handle. Obviously, in this case, we want the select speaker navigation handle in this case. And when we're ready to deliver a result, all we've got to do is call close with result. That's it. The screen closes, a result is delivered. In this example, obviously, we're creating a new speaker ID every time. In reality, you have a list and you'd have different IDs, and that would all fit together nicely. And for example, if we decided we didn't want to close with a result, we wanted to cancel from the screen, instead of calling close with result, we just call close. All right, so that's pretty simple, but where this starts to maybe get a little bit more complicated, and like looking back and thinking about the screen as functions, is when we want to add a new speaker. How might we look at solving this problem if we were thinking in functions? Well, you might do something like this in a function. Obviously, this is sort of imagined code, but you'd start the function, you'd decide, should we create a new speaker? If we should create a new speaker, we can return early and delegate that result to our create speaker function. You know, we don't really care what create speaker does. We just call another little piece of independent functionality and provide that result instead. So how does this look in Enro? Well, it looks pretty simple, really, I think. Imagining we have a create speaker navigation key, some other navigation key that also has a result of speaker ID. From our select speaker screen, we can, instead of calling close with result, we can deliver the result from pushing some other screen, which is essentially the same as like delegating the result to another method if you're thinking it, or another function if you're thinking in functions. So it's quite easy to like connect these independent screens. We don't care how create speaker works. We just know that it has the same return type as we do, and so we can delegate to it. All right, so how might we actually retrieve this result from the session screen? So in the session screen, we obviously want to get this speaker ID and do something with it. And this is a little bit more complicated, but hopefully it's a little bit familiar because we use something called register for navigation result, which is an API inspired by the activity register for activity result API. Basically, the way that this works is you create a result channel by registering for a result. We say that we're expecting a speaker ID in this channel, and we provide a callback that will be invoked whenever a result is delivered through the channel. When we want to, in our session details screen, get a result, kick that process off, all we do is we call the channel select. Instead of pushing to our navigation handle, we push to that particular channel and present a navigation key that has a result of a type that matches what we're looking for. So in this case, we're looking for a speaker ID. We can present the select speaker screen. And obviously when that result is delivered, we're going to call on speaker selected, which is, you know, some other piece of code somewhere. We don't need to worry about that. You know, that's implementation details. So if you sort of put this all together, we have an example app here. Oh no, actually, sorry, I'm getting ahead of myself. All right, more complicated than these individual results. We have this idea of a multi-step flow through an application where, you know, there's one screen after another until you reach the end and sort of the whole process creates a result. Now, if we were thinking about this create speaker flow where you enter name, a headline, a biography, email, etc. to create a speaker, how might we think in functions? Well, you could think using a similar like delegation sort of method where you might have a create speaker function which decides that it should start off by calling create speaker name, which create speaker name would get a string from the user before it passes on that information and delegates out to create speaker headline step, the next function in the chain. And then the headline step would get another string from the user and delegate on forward until the end, where we reach save speaker, which would return a speaker ID and then sort of collapse all the way up. And you can think of this as working like this, right? Where the name step knows that it wants to go to the headline step next, then to the biography step, and then return at the end. Now, this isn't actually a very natural way to write functions. So if we were really going for the function mental model, we might be wanting to do something a little bit more like this, which feels like a much more natural way of writing code, right? Create speaker is a function that returns a speaker ID. First thing we do is we get a name, then we get a headline, we get a biography, we delegate off to those. We don't really care what those functions do. We just know that they give us the name, headline, biography. Then we create a speaker object. We can save that object to a repository, and then we return the speaker ID at the end of the function. This is a sort of slightly different way of approaching the problem. And if you draw this out, this is the way I think about this, which is that instead of each screen knowing about the next screen in the step and delegating in this big, big, long chain, we instead have this sort of outer flow managing the screens inside. And those screens inside, they don't know about any other screens in the flow. They're really independent from one another, and they return results up to the flow who decides what the next step is. And you can do this in Enro using what is called a managed flow destination. So instead of appending navigation destination to a composable, we say we're actually going to build a managed flow here. And that managed flow gives you a little API where you can push and present destinations as almost as if they were suspending functions. This isn't a suspending function, but it works in a very similar way. Start off at the name screen, push to that, get that result. Then go to the headline screen, push, get a result. At the end of it, create a speaker object. Then at the end of this, we can write a definition of what we want to do when that whole flow has completed. So here we're going to save a speaker and then close the whole flow with a result. So when you sort of tie this all together, this is from the example app, we would see behavior like this, where we can select a user, update the session, we decide we want to create a new speaker, we go through the multiple steps here, and then this is probably a little bit slow, but at the end here, you will see that this is going to ping us back to the session detail screen. It's going to be updated and we're going to have a new user. Now, this works great as an example, but how well does this work in reality? What is this actually like to use? Has this idea been tried in production? Well, if we're talking about some lessons from reality to wrap things up, really, I think that this is a really, really powerful way of working, and it changes the way that your application architecture hangs together. The way that you think about screens, if you're thinking of them as these independent reusable functions, means that it's really easy to build like complicated managed flows like this. For example, at ANZ Plus, we use the managed flow functionality in some of our screens, and you can inject logic there. You can go to this screen if the previous screen returned a certain result. And all those individual screens are really easy to understand and manage because they don't need to know about their context in the application. They just know that they get some input and they produce a result. It's, I think, quite a powerful way to work. And obviously, like I was saying, has this been tried in production? Yes, we're using this at ANZ Plus. We've got about 600 of our screens are using Enro, which is about 80% of the screens in the app. It's also being used in Splitwise as well, if you're familiar with that app. And talking about scalability, I have a friend who has a small hobby project. It is like his side project. It's probably going to turn into something maybe a bit bigger in the future, but that's called Beyond Budget. It's like a budgeting app. It's got about 110 screens. He's been working on it for a wee while. And he's one engineer in his spare time, and he uses this model, and it works just as well for him as it does for us at ANZ with our 600 screens. And I asked him for a quote, which is maybe what I will leave you on, because he does say that he quite enjoys using Enro and this different way of thinking. And so the quote from him is, "The return types are something else. It's a game changer and the enabler of micro screens, which can be used everywhere. Because you grab another destination and open it, you get that result, and the screen doesn't even really need to know about how that works. Once people really get to understand how this works, there is no other alternative for such flexibility." So I would like to suggest that you reimagine navigation and the way that you think about screens in Android applications. Take a different perspective. Whether you decide to use Enro or look at that at all, or build your own tooling, or just look with a different perspective at your existing applications, take a chance to reimagine navigation as functions. And that is the end. And here are some links for the Enro website as well as the Devfest sample. I'm happy to take any questions, and I also have the example project on my laptop if anybody wants to come and talk to me after this presentation and actually see things running.
Easy one for you. What is Enro? Like what's behind the name?
Is anybody familiar with a website called The Codeless Code? Okay, so it's basically a collection of stories and fables written like in the style of sort of Zen monks interacting with each other, but the monks are all programmers, and they sort of have morals of the story that are related to programming, you know. And there is a story there where somebody gets called Enro as part of the story, and I liked it, and so there we go. I think it means garden path, or like frequently traveled area, like through a garden or something like that in Japanese. That is at least what it says in the story, that the meaning is.
Hey, I take it that ANZ, ANZ Plus, and Splitwise are locked in portrait and don't target tablet.
No, that's not the case.
Okay, so you've dealt with, or this has been tested in situations where screens can be vastly different, or the classic portrait screen is reused alongside other screens. What kind of complexity does that bring?
So that gets into probably like some of the guts of how you wire Enro up to use in an application. Like taking tablet and tablet, larger screen devices, a common pattern as an example, like a list detail kind of view. That the way that you would do that in Enro is you would essentially, when you're wiring things together and saying like, where should screens go in the UI, you can have two different navigation containers with independent backstacks and like hide them and animate between them in portrait mode, but then lay them out next to each other in landscape mode. So yeah, you can certainly do stuff like that. That's, again, one of the things that I really like about working this way is that that's really a completely UI concern, like in terms of the structure of the screen, like visually, as opposed to being part of the navigation logic and how the screens hang together. You know, I hope that answers the question.
And can I ask another one? You know, if we're interacting with other apps, right? You've got to start activity for result, for instance, and so then you've got to use the classic kind of concepts for navigation. Does that compromise this approach?
Well, not really, because it's quite easy to write wrappers and things around stuff. So like Enro, the examples I showed are all composables, but it supports activities and fragments. Like you can just chuck in navigation destination annotation on an activity or fragment. So like, for example, if you wanted to wrap away a start activity for result, you could start a fragment or like a small composable to do that. Or there is functionality in Enro as well, something called synthetic destinations, which are almost like destinations that don't really exist. They just run like a little piece of code as if there was navigation happening. And there is support to, like, particularly for the activity result example, using activity result contracts, you can sort of shortcut yourself into turning that into a navigation key that has a result at the same time as the activity result. Oh, I don't know. There's too many people. Okay.
Great talk, thanks. Question about deep links. Are there any special considerations? Say, for example, if I want to deep link to a speaker bio page in the traditional way, are there any special considerations in Enro that I need to be aware of?
Not really. Enro doesn't talk about deep linking or make any decisions about deep linking or the way that you work. So the way, like, for example, a common way that you might do this, I was mentioning Enro has this concept of navigation containers. Containers can hold other containers. They have their own backstacks. You know, you would retrieve an intent on your intent for your activity or whatever, parse a route out, and then that would be your responsibility to decide, okay, so I'm going to find this container, and I'm going to put that in that container, and then I'm going to grab this other container, I'm going to put these three things in the backstack, and then cool, go. So yeah, you sort of manage that yourself, but it's reasonably easy. I think we had one.
I think we're out of time, but
just offer it.
all right. Have you had problems with complex state management? So like, have you ever been tempted to like break that function purity, reach for some kind of external state, or have you not had any issues with that? Like, can you just keep everything as a pure function, no external state required?
No, I think you need external state when you're using, like, building any sort of complex app, right? But to me, the complex state is separate to handling the navigation and how the screens hang together. Some examples that I didn't really show here is that you can actually get navigation handles inside of view models externally from the UI. And so it's quite common to, if you want to, you can grab a navigation handle inside of a view model. Your view model grabs external data state from the repository or whatever. Maybe it does a suspending function and sets up a loading state while it, you know, performs that save action or something on the external state before closing with the result, or before deciding to navigate to a particular other screen. I'm not quite sure if that is answering your question in the right direction, but
I guess so. But so as in you would keep it in the repository, whether it's a local or a remote repository, I'm assuming is what you're saying.
yeah. Also, we are running over time, so like, if you want to go to lunch, I'm not going to be offended by that. So.
Yeah, I just had a question about what's the migration story. If let's say you're in an app where you're using kind of the more traditional frameworks, if you were to migrate to something like this, is it like an all or nothing kind of thing, or can you tweak kind of piecemeal, like, or do you have like a migration path that you suggest?
It's reasonably easy to do it piecemeal, I've found. So my friend with a small app, he did like a big bang migration away from AndroidX. The ANZ Plus has been like a very incremental migration away. We actually, from a different library called Conductor, and we wrote some interop, basically Conductor Enro interop stuff to let us easily migrate away from fragments and activities or AndroidX Navigation. Yeah, again, you can do things in a piecemeal way. You sort of pick individual bits that you might want to migrate, you know, a small part of a subgraph, and then eat all of the nodes in the navigation graph upwards until at the root you can change from using like an AndroidX Navigation to a Enro. Thanks. Cool. All right, I think that's about it.